Hello everyone, welcome to this channel just in 2 pages. Today in this video we are going to talk about designing of shaft, and we'll begin it with another numerical problem which is based on a different formula. The formula is T upon J is equal to Fs upon R is equal to C theta upon L. Here T is the twisting moment, J is the polar moment of inertia, Fs is the shear stress, R is the radius, C is the modulus of elasticity, theta is the angle of twist, and L is the length of the shaft. So when we take these two, it will become the strength of the shaft, and when we take this two along with this two, it will become the stiffness of the shaft. So here J is always taken as J, which is the polar moment of inertia. For solid shaft it is always taken as pi upon 32 into d raised to the power 4, and R for a circular shaft, mainly the shaft will be circular, so R will mainly be d by 2. Is that design a shaft required to transmit 97.5 kilowatt of power at the speed of 180 rpm. If the allowable shear stress in the material is 60 Newton per millimeter square, the shaft should not twist more than 1 degree of angle if the length of the shaft is 3 meter, and C should be taken as this. So first of all, we'll begin with writing the information that has been provided in the question. So we notice that the power is 97.5 kilowatt. We can write it as 97.5 into 10 raised to the power 3 watt. N is the speed of rotation, that is 180 rpm. Fs is the maximum shear stress, which is 60 Newton per millimeter square. Theta is the angle 1 degree, so we should convert it into by multiplying it pi by 180, so it will be converted into radian. Length is 3 meter, it should be multiplied by 1000 and it should become 3000 per millimeter. After writing all the information that has been given, we also come to know a formula, that is power is equal to torque into angular velocity. P stands for power, T stands for torque, and omega stands for angular velocity. We know that power is given in the question above. We have to calculate the torque, but for calculating the torque we must know power as well as omega. So we know that it is the angular velocity, and the formula for angular velocity is 2 pi n upon 60. So by putting the power 97.5 into 10 raised to the power 3 is equal to 2 into 2 pi n upon 60, where the given value of n is nothing but it is 180. So after solving all this, we'll come to know that T is nothing but it is 5.172 into 10 raised to the power 3 Newton per millimeter square. Once we come to know the value of T, we can easily go for finding out. Now the mechanical properties of the shaft are found on basis of two different things. The first one is the strength of the shaft. The strength of the shaft is calculated from the very first part, that is T upon J is equal to Fs upon R. Here T stands for torque, J stands for polar moment of inertia, which should be taken as pi by 32 into d raised to the power 4. Fs is the maximum shear stress, which is given in the question, and here R should be taken as d by 2, that I have already told you. R should be taken as d by 2. After knowing all these values to the question, we'll come to know that the D is 7.6 mm. So for the strength of the shaft, the D is 7.6 mm. Further, if we try to go for the another thing, that is the stiffness of the shaft. So stiffness of the shaft is calculated by T upon J is equal to C theta upon L, where T is the torque, J is the polar moment of inertia, C is the modulus of elasticity, theta is the angle of twist, and L is the length. We can easily notice that all of the materials are given in the questions. So here J will be taken as pi by 32 into d raised to the power 4. And theta we have already converted into by multiplying by pi by 180 into radian. Now, using all these materials given in the question, as t is 5.172 into 10 raised to the power 3, j is pi by 32 into 10 d raised to the power 4. Here the value of c in the given question is 80 into 10 raised to the power 3, and we have converted theta, that was 1 degree earlier, by multiplying it pi by 180 and divide the whole length, that is 3000 millimeter. After calculating all this, the value of d will comes out to be 18.3 millimeter. So in the earlier part, the value of d was 7.6. Here it is 18.3. So this value is maximum. So hence we will consider this value for making the shaft. Thank you.